It's Monday, November 28th, 2022. I'm Jonathan Lau, and this is 5 Minutes of Proof, a weekly analysis of the science behind ozone therapy. Today, we're going to continue looking at an article or document entitled The World Federation of Ozone Therapies Review on Evidence-Based Ozone Therapy. And we're going to skip on past what we took a look at last week and jump into Chapter 1. We'll get through this and a couple other chapters that are very short here today. So what are we talking about here? Well, Chapter 1 is Physical Chemical Properties of Ozone, Natural Production of Ozone, and its Toxicity. And they start off by saying it is useful for the physician to know the solubility in 100 milliliters of water. And they mention the temperature there of both ozone and oxygen is 49 milliliters and 4.89, tenfold less respectively. So ozone is much more soluble than oxygen in water, 10 times more so. Consequently, ozone's great solubility in water allows immediate reaction with any soluble compounds or biomolecules present in biological fluids. Then they say among oxidizing agents, ozone is the third strongest after fluorine, which is a gas, and persulfate, which is a substance, white powder, a fact which explains its high reactivity. So very reactive, very powerful as an antimicrobial. Also, this is helpful. The half-life of ozone molecule depends on temperature. We've talked about that before. Thus, at 20 degrees Celsius, ozone concentration, so that's your average 70, 75 degrees Fahrenheit, is half in 40 minutes. At 30 Celsius, so when it's pretty hot out, it's 25 minutes, so it decreases significantly. And this is something I haven't read before or seen before, so I'm going to take this with a little bit of a grain of salt and look for more evidence. But while at minus 50 Celsius, it's halved after 3 months. So that's interesting, and I'm not sure where that research comes from, but I will try to find more on that. Research in human activated leukocytes producing ozone in specific circumstances may be significant in understanding how useful it can be in physiologic and pathologic situations. So here we're looking at actually the endogenous production of ozone. So they're looking at ozone, then they're saying, hey, you know what, this is produced in our bodies by leukocytes at times. And so that's important to recognize that, hey, it probably does have some therapeutic value, even just by looking at that one area. So the World Health Organization allows working for 8 hours when ozone concentration is 0.06 parts per million, being perceived well in advance as a strong smell of ozone. So here's the deal. You can smell ozone at that concentration. If you're working for 8 hours in a location and it has 0.06 parts per million, the World Health Organization, the EPA, I think it's 0.08 maybe, but I'm not. Don't quote me on that. Say you're safe. Now, keep in mind that is continuously at that level. Now, when we're doing ozone therapy, sometimes we'll smell some ozone, but it's not continually being produced into the air, so it dilutes in the air, so we might have a higher level for a very short amount of time, but over 8 hours, our part per million is very, very low. And here's just some information on the conversions between part per million and microgram per milliliter. So you can take a look at that as well. Chapter 3, to look at ozonated water and oil. So in the case of water, about 5 minutes will be enough for 2 or 3 liters. Okay, and again, this is a little different than what we've advocated in the past. The research that I've seen on this, and I think we've reviewed that study here before, says about 5 minutes for every 250 milliliters. So that's what we stick with. But this is interesting to see that, it probably would be enough if we're looking at the therapeutic usage of ozone and using it immediately, certainly 5 minutes for 2 or 3 liters would still be a therapeutic dose. But we're talking about 250 mLs for 5 minutes to fully saturate that fluid. And they mention vegetable oil and ozonating that, in that it can take hours. But they also mention this, which is very true. We must take into account that many ozonides composed in vegetable oils are of an explosive character, thus entailing a potential danger. Subsequently, it is not advisable that unskilled people should perform this procedure. This is why ozonated oil is produced basically in semi-industrial laboratories, following safety measures and with the appropriate personnel. I would concur. Air must not be used to produce medical ozone because it makes some toxic nitrogen compounds. And one other quick note, ozone concentration in pure water due to solubilization of ozone corresponds to about 25% of the ozone concentration in the gas used at room temperature, which is enough for optimal disinfection. So if you use 100 micrograms to ozonate the fluid, about 25 will be absorbed. And then finally, efficacy of ozone has been validated by over 3,000 municipal water treatment plants throughout the world. Well, that's it. This has been 6 minutes of proof. We'll see you next week for another edition.